Hello guys and welcome. I hope that you're doing well. My name is UHDking or I play 4K, AK I play 8K, AK I play 16K, and during this video I'm going to demonstrate Metra Last Light PC game running in 16K video resolution. This is going to be the world's first 16K video resolution benchmark in Metra Last Light PC game. Okay, before we're going to jump into the benchmark, let me real quick demonstrate for you that my desktop today is running 16K video resolution. As you can see, I'm using the Microsoft magnifier zoom tool, which is great application. This is within the 500% zoom, 600, 700, 800, 900, 1000. Let me zoom in a little bit more for those folks that watching this video on the iPad or tablets. So 1600% magnifier zoom tool is maximum zoom, and as you can see, yes indeed, my desktop is 15,360 pixels by 8,640 pixels, 100% display scale. This is very crucial. Make sure it's 100% just in case that is going to render 16K video resolution 100% native. Okay, so how I achieve that? I'm using the Nvidia DSR, and I'm using the 8K resolution native screen. So it's going to be output today on 8K resolution native screen. However, I'm using the DSR and it's rendering in native 16K video resolution, and then it downscaling to 8K video resolution. But it's not upscaling to 16K video resolution. It's rendering natively 16K video resolution through the Nvidia DSR tool, and then it's downscale and outputting to the signal to my 8K video resolution screen. In the end of this video, we're gonna go in details while I'm going to explain to you PC configuration system, and I'm going to underline why 16K video resolution is the maximum video resolution. Okay, so let me real quick go ahead and overclock the video card, and we're going to jump into the benchmark. So as you can see, I'm going to use a lot Microsoft magnifier tool. So right now Titan RTX running stock, but keep in mind that I already pre-bench Metra Last Light PC game in 16K video resolution without Nvidia ShadowPlay recording. Right now I'm recording with Nvidia ShadowPlay in 8K video resolution because my Nvidia driver and Nvidia ShadowPlay gaming experience is modified. Keep that in mind through the RAM debugging tool. If you're a software developer, you know exactly what it is. So I'm going to overclock the Titan RTX. You want to keep your eye at the pixel fill rate, textual fill rate, and the bandwidth of our video RAM will increase, and I'm going to pretty much be faster than RTX 3080 video card video RAM bandwidth, but RTX 3080 video card will have much higher bandwidth than Titan RTX running stock. But this is the stock value right now on Titan RTX. Let me go ahead and overclock it. I'm using the CPU noise removal from my microphone, and it's using the artificial intelligence. I'm not using the Nvidia RTX voice removal, which is great, removing the noise, but it's utilizing some GPU. So I'm using the CPU artificial intelligent noise removal from my voice while it's recording through the mic, and it's not even stressing 1 FPS because I'm sitting by the computer and it's having the Titan RTX dual fan stock, air cooler stock by Nvidia, by manufacturer, not modified at all, but liquid metal on GPU and thermal compound paste on the better thermal compound paste on the video RAM. So it's overclock. As you can see, by the stock RTX 3080 video card bandwidth is going to be 769 gigabytes per second, and right now I'm running almost 800 gigabytes per second. Okay, still not as fast as 3090 Ti or 3090 or even RTX 3080 Ti or RTX 4080 or 4090 video cards, but it's still fast and faster than RTX 3080. And on GPU computing performance power, RTX 3080 and Titan RTX will be the same, except the RTX 3080 will be faster stock to stock on the video RAM. Alright guys, so in the end of this video we're gonna go in details through my PC configuration, but we're going to run 10 presets. This video is not going to be as fast as possible, but this video will be around over 1 hour. Go ahead and grab yourself your favorite drink. The best drink will be water with the lemon or tea with the lemon, and this is the preset. So I also included the AF 4X for those who's curious. So low preset 4X, 16X AF. medium AF16X, high AF16X. Of course, motion blur will be low all the time because the FPS will be low, and you want to use the motion blur when your FPS 60 or above. Keep that in mind. Otherwise, everything will be so distorted and looking not the way it should be. Then very high preset AF16X, then tessellation normal at very high preset AF16X, then tessellation high at the very high preset AF16X, then tessellation very high, and then advanced physics is on. And then I'm going to also show you the low preset AF16 and tessellation very high and advanced physics on, for those who is curious. Okay, as again, I already pre-benchmark this tests, and we're going to have two different results: without Nvidia ShadowPlay recording in real time on the same computer, and within Nvidia ShadowPlay recording. So we're going to find out how much exactly, but this video will demonstrate as a proof, as a fact, that yes, indeed, it's rendering 16K video resolution, and this is exact how much performance it will take to render 16K video resolution. So in your installation of your folder, it's going to be two files. How to run this benchmark for those newcomers that would like to benchmark their system and compare. Two files: Metro LL executable. This is for the Metro Last Light executable. This is the Steam version of the game client Metro Last Light PC game. And then it's going to be Metro LL benchmark.executable. Go ahead and run this. It's going to bring you to the benchmark and set exactly as I'm going to do. So this is how we're going to do it, guys. And let me show you again the benchmark. How I think it's too much on the zoom. As you can see, I'm using the 36 megapixel as my wallpaper taken with the Nikon D810, but it's upscaled to 8K to 16K video resolution desktop. So right now it's upscaling and stretch a little bit of the pixels, but Nikon quality is great, as you can see, even when it's upscaling. I really like it. It's much better than Canon or Sony, even if it's using the same Sony sensor, but the way they're producing the pixels is a little bit different on the Nikon sensor, even if it's the same sensor as Sony, but the image processing is different on the hardware. Anyway, so this is yeah, the presets that we're going to use, and I'm going to go ahead and execute now. I'm going to click run all, and let me overclock. Titan RTX is overclock. Excellent. And yeah, I'm going to share a lot of information as graphics designer, 3D artist, game developer, software developer, hardware guru, hardware enthusiast, PC overclocker, software engineer, and as a gamer as well. So a lot of great things will be shared, guys. I'm gamer and PC gamer since 1996. Keep that in mind. Anyways, let me go ahead and run it all. It's going to tell us it's going to take some long time. Do we want to execute it? I'm going to say yes. Let's go ahead and execute that. And we're gonna go ahead and execute that. So it's running right now, and keep in mind this is going to be a single take. I'm not going to edit this video. Okay, so the way you're gonna see and the way I'm going to experience that, I'm going to come in real time, which will be the best way. So this is the lowest possible preset, AF4X. It's going to run 3 times every single benchmark to collect the best possible value as a data. The data at the left top, self-explanatory. Every single value is real value, as again it's rendering in real time and updating in every single second. As you can see, 16 FPS average. The latency delay, MS stands for the milliseconds. It's at the left top corner by the FPS. The milliseconds latency delay between the software and hardware. We want to have the value as low as possible in terms of the MS, and in terms of the FPS we want to have as high as possible. Okay, comfortable FPS will be 60 FPS on average, and latency delay in terms of the MS will be below 20 milliseconds comfortable FPS. Please keep that in mind. But of course, this is going to be the world's first 16K video resolution benchmark in Metro Last Light PC game on the hardware such as Titan RTX video card that is equipped with 24 GB of video RAM, GDDR6 by Samsung, and Intel Core i9-9900K overclock at 5.3 GHz, but only using 6 core 6 threads, 2 physical cores disabled, and hyper-threading technology with additional 8 logical cores disabled because they're kind of slow. On Intel 9000 series CPUs, 3 logical cores is equal 1 physical core. Please keep that in mind. So that's why I disabled the hyper-threading technology. So we are pretty much utilizing the Intel 9000 series to the best as possible, and pretty much we're utilizing the Titan RTX video card and TU102 GPU to the best possible abilities, because 10900K CPU at stock will be slower than 9900K at 5.3 GHz. 11900K will be a hair faster, and 12900K doesn't support SLI on the motherboard, as well as 13900K doesn't support SLI on the motherboard. And keep in mind that I have two Titan RTX video cards, and I'm going to test two Titan RTX video cards in SLI just to utilize the Turing GPU architecture by Nvidia to its maximum. And those type of technologies and newer CPUs doesn't support SLI, so pretty much this is the Turing GPU architecture by Nvidia pushed to its best. I would say it like that. Look at this, it's beautiful visuals, even at low preset. It looks like 4K resolution, very high preset, to be honest with you. Everything is so detailed because the amount of pixels right now we under 132.7 megapixels, which is 16K video resolution, 15,360 pixels by 8,640 pixels, exactly 132.7 megapixels, or 1/10 of the gigapixels rendered in real time. So per every second we're rendering right now 20 times 132 megapixels. So we're rendering right now almost 1 gigapixels in real time. But more than a half gigapixels per second, because it's built up through different frames, 20 frames, and each frame is 132.7 megapixels. So Turing GPU architecture is the first video card that is capable to run Metro 2033 PC game, Metro 2033 Redux PC game, and Metro Last Light PC game, Metro Last Light Redux PC game, Metro Exodus PC game, and Metro Exodus enhanced PC game in 16K video resolution. And of course, two Titan RTX video cards in SLI will demonstrate almost twice as much as performance if SLI supported, and I believe Metro Last Light supports SLI because previously I tested, and I'm going to show you in Metro Last Light with two Titan RTXs in SLI. Benchmark, guys, is going to be nice to see as a second vertices or a second coordinate towards 16K video resolution benchmarking in Metro Last Light PC game, and this is going to be the first vertex or the first coordinate towards the 16K video resolution benchmark in Metro Last Light, guys. And of course, it's not playable experience, but at least it's benchable in real time. And with the newer video cards, newer CPUs, newer PC systems, newer computer systems will deliver better result. But at least we're going to know that Turing GPU architecture is the first video card, which is Titan RTX, that is capable to run a Metro Last Light PC game in 16K video resolution as a first video card. And then we're gonna test with the RTX 3090 video card, RTX 3090 Ti video card, RTX 4090 video card over the UHDking.com, so you don't want to miss. And if you into 16K video resolution benchmark, 16K gaming, 16K gameplays, go ahead and check out 15,360 times 8,640.com website. It's by UHDking, will be dedicated to 16K video resolution, 16K gaming, 16K gameplay. Keep that in mind, guys. As again, I'm coming in real time, and this is the best way to provide the best amount of information for you, pros and cons. So it's great performance, by the way, and two Titan RTXs in SLI will demonstrate almost playable experience for the old school gamers. It will demonstrate almost like 30 FPS on average, or even sometimes above 30 FPS on average, depends to the scene at this type of preset. Please keep that in mind. As you can see, my video RAM utilization below 11,000 megabytes. Please keep in mind at the video RAM, at the system RAM utilization, because when it's going to increase, that's going to be a clear sign, especially when it's going to increase by a lot. It's going to be a clear sign that we are floating some data from a video RAM into the system RAM. And system RAM, guys, is at least 12 times slower stock to stock than the video RAM today. My DDR4 3200 MHz CL11, which is pretty much the fastest possible scenario for the DDR4, because I'm using CL11 1T command. It's not CL16, not CL15, not CL14, it's CL11. The low value in terms of the latency is better for the DDR4, and it's demonstrating 50 gigabytes per second or 50,000 megabytes per second bandwidth, and compare that bandwidth versus 690 gigabytes per second bandwidth out of the GDDR6 by Samsung that is equipped as video RAM on our Titan RTX. You can see 12 times at least more or faster than our DDR4, and that's why when we are offloading some data from a video RAM when it's not enough, so driver is not crashing the game but it's still trying to run the game but offloading some data, it's running slow FPS and high latency delay because the system RAM is not as fast as video RAM. Hopefully guys I explained it good enough for the newcomers. Look at this, the game looks beautiful, and this is without the tessellation yet. And this is just unbelievable. This is going to be the last test, and we're going to switch to 3 more tests on a low preset but 16x anisotropic filtering for the textures. And pretty much what it does is just smoothing the pixels. It's blurring the pixels when AF4x, not loading the full amount of details of the texture, and when it's 16x it's loading every single detail of that texture. Please keep that in mind. But under 16K video resolution, even when it's applying that artificial methods for the blurring the textures and loading a little bit less data, stressing a little bit less of the video card resources, it's still under 16K video resolution is going to deliver unbelievable amount of pixels guys, because 132.7 megapixels as native rendering right now. No matter what kind of artificial intelligence limitation the game developers will be using today as a 4A games from Ukraine, while running 4A games game engine, it's still going to guys render a lot of megapixels in real time. Alright, so it's going to be low preset 16x. We had a beautiful FPS, but for Turing GPU architecture it doesn't matter, low preset 4x AF or low preset 16x AF, it's still going to be great FPS. Maybe the difference will be 1 FPS when you're below 30 FPS. When you're below 60 FPS, maybe the difference will be only 2 FPS. When you're below 120 FPS, but on average like 120 FPS. Maybe when you're running AF4X versus AF16X, maybe the difference will be 3 FPS. But there is no such a difference for Turing GPU architecture. Has no problem to utilize that algorithms when you're switching between the anisotropic filtering and applying all kind of different algorithms to the texture, artificial algorithms, and it has no problem guys, as you can see, for that type of mathematics. And yeah, still great FPS. 2 Titan RTXs over here will show like 35 at least FPS average if both GPUs will be scaling at 100%. Another thing is going to scale less than 97% for 2 Titan RTXs and SLI for those 2 TU102 GPU. But as again, because the first video card will be very hot and is going to thermal throttle closest to the CPU when you're running 2 of video cards, and if I'm running 2 of them on air cooling designed by the Nvidia, which is dual fan design stock, and this is exactly what I'm doing. I'm running stock. Most likely it's going to thermal throttle, and FPS not going to be 2x but going to be like 1.85x because it's going to run a little bit lower frequencies on GPU. Keep that in mind, because it's going to thermal throttle the GPU due to the hottest first video card temperature closest to the CPU. But this type of scenario is always when you're running SLI. As again, SLI is supported only on DirectX 9 API, DirectX 10 API, and DirectX 11 API. It doesn't support it on DirectX 12 API. DirectX 12 API is using multiple GPU approach versus the SLI, and Nvidia decided not to support it because it's already built into the DirectX 12 API, and all what developers need to do just use that classes and through their game engine. But not all developers doing that. A lot of them are lazy, but it's already pre-built, so Nvidia decided not to waste their time and not to create the profiles when developers can do it, and it's going to be the best way possible. Alright, so the FPS still above 10 FPS but below 20 FPS average. As you can see, latency delay will be above 60 milliseconds, and VRAM utilization will be below below 16,000 megabytes, which is below 16 gigabytes, and system RAM utilization will be below 11,000 megabytes or below 11 gigabytes. Not bad, not bad. We still do go like 8 gigabytes for our VRAM utilization. We can still utilize about 8 gigabytes for sure. And the system RAM utilization total I can utilize today 32 gigabytes. I having 32 gigabytes of system RAM. But when you're going to see when it's going to jump above 11 gigabytes, that means a clear VRAM overload. Hopefully it's not going to happen. I tested with the SSAA, which is anti-aliasing in this game, and it crashed. So it's going to be our separator between the test when it was recording with Nvidia ShadowPlay and when it was not recording with Nvidia ShadowPlay. Okay, great FPS, guys. And low preset, as you can see, and medium preset, the FPS will be almost the same as Metro 2033 or Metro 2033 Redux, almost the same FPS. And this is a great result for the Metro Last Light, because Metro Last Light PC game was a little bit heavier than Metro 2033, but it was heavier on the old GPU architectures. As you can see, it's perfectly utilizing the newer GPU architecture. So for a game engine by the 4A games, it's great game engine because it's pretty much it's soft overlay on the DirectX 11 API, and it's not using a lot of artificial limitations. And as you can see, game engine has no problem for a game engine by the 4A games developers from Ukraine, has no problem to run the game in 16K video resolution. You just need to have the powerful GPU to be able to run it in a playable FPS, such as I would say RTX 4090 video card at least. And I cannot wait to test it on RTX 4090 video card, either GPU architecture or on the RTX 4090 Ti video card, especially on the RTX 4090 Ti video card or newer Titan, whatever Nvidia going to call it, because today is November 2022, and with the AD GPUs, which is AD GPU architecture by Nvidia, they only released the flagship as RTX 4090 video card. But RTX 4090 video card is not utilizing full AD 102 GPU that has a lot of potentials to go. The difference between the RTX 4090 video card and the newer RTX 4090 Ti or newer Titan will be single Titan X Maxwell GPU architecture, and I'm pretty sure it's going to bring some improvements. It's going to be at least over 10% of the improvements. So I cannot wait to test it with the full AD102 GPU. But RTX 4090 video card will be always and also a great video card to test, because the RTX 4090 video card is at least 3 times faster than Titan RTX video card. At least, this is as minimum. So your FPS should be at least 3 times faster, as you can see right now. Titan RTX producing FPS. If the AD102 GPU or ADA GPU architecture in RTX 4090 video card, which is cutted version of the AD102 GPU, not full version of the AD102 GPU, will show 100% or 99% GPU utilization, just like Turing GPU architecture is showing right now at the left top. The FPS performance will be 3x as minimum. So over here it's going to be 60 FPS, and now on RTX 4090 video card the FPS will be playable. Maybe it's not going to be playable comfortable status, but it's going to be playable status for the old school gamers for sure. And I cannot wait to test on RTX 4090 video card. So guys, please support me, smash that like button, subscribe, visit my sponsors, and positive comment, share it with your fans so more people can see it, and I will collect those pennies and I will invest as soon as possible into the RTX 4090 video card. But as you can see, I'm trying to wrap up with the Turing GPU architecture Titan RTX video card, while I covered in all possible ways as a single Titan RTX video card or as a 2 Titan RTX video cards, while as professional gamer and professional PC hardware enthusiasts that already own the 4 Titan X Maxwell GPU architecture, 4 Titan XPs, 2 Titan Voltas, 2 Radeon Pro Duo video card, which is 4 AMD GPUs in Crossfire, 4 R9 290 in Crossfire. So I have a lot of information to share as PC hardware enthusiast, PC overclocker guys, and at the same time as a software developer, game developer, graphics designer, 3D artist, a lot of experience under my shoulders, and or I would say on my shoulders, and I'm going to share a lot of information through my videos. So you want to subscribe to UHDking.com YouTube channel guys, share it with your friends. It's a great YouTube channel. It's not like those copycats copying each other and saying the same stuff all over. Over here there is unique information and 16K video resolution, pretty much the maximum video resolution in terms of PC gaming. Before PC gaming will be dead in 2027, but we're gonna see 16K video resolution displays before we're going to switch to the holograms and glasses while utilizing the VR and AR technologies. But I heavily believer in the AR technologies versus the VR technologies. Keep that in mind. Anyways, this is going to be guys the medium preset now. FPS will be a little bit lower, but as you can see, not too much, by about 2-3 FPS lower, and medium presets still are great visuals. As you can see, just because they match our last light using the bluer, low, medium, or high, and you cannot turn it down, unfortunately. So that's why it's gonna give us a little bit of the halo effect through the motion when your FPS below 30 FPS. And in our case, no matter what kind of preset we are going to use under 16K video resolution on a single Titan RTX video card, no matter what kind of CPU in the future we're going to use, our FPS will be below 30 FPS for sure. Okay. And as again, 13900K doesn't support SLI, so I cannot connect two SLIs, guys, to Titan RTXs and video card, even if that CPU will deliver as at least 15% more in terms of the FPS when compared with the i9 9900K overclock at 5.3 gigahertz. Most likely it's going to deliver over here about 3 FPS as minimum. As you can see right now, it's not going to be too much. It's not going to be like you're going to install the RTX 4090 video card on this CPU when my FPS will be at least 3x even on this CPU, but it's still going to be faster. But unfortunately 13900K motherboard doesn't support SLI technology. So pretty much right now you're watching the Turing GPU architecture almost pushed to the maximum. You can push it to the maximum with the 10900K overclock at 5.3 gigahertz, and at least you're going to receive, I would say, maximum 2 FPS higher than you can see right now. But this is pretty much going to be top for the hardware that is capable to run Turing GPU architecture as 2 video cards. But as a single video cards, yeah, you will be able to push it with the newer CPUs, but pretty much you're not going to deliver over 5 FPS higher that you can see right now at the left top corner, no matter what kind of CPUs you're going to use. Even if you're going to use the CPU technology from 2027, maximum you will deliver 4 or 5 FPS additional, and not higher than that. So pretty much right now we're pushing the Turing GPU architecture to its max, especially when the i9 9900K overclock at 5.3 gigahertz, and it's pushing higher instruction per clock right now because it's having the higher frequency and impulsing faster, so pushing more instruction per clock automatically through the physics. So level second cache in Turing GPU architecture will be 6 megabytes, same as on RTX 3090 and 3090 Ti video card, but RTX 4090 video card featuring 72 megabytes of second level cache or level second cache on a GPU, and but 8102 GPU architecture featuring 96 megabytes of level second cache. So exactly that's why it's going to be newer Titan. Hopefully Nvidia going to release Titan King or something like that, but we'll equip it with the 48 gigabytes of video RAM so we can explore the full EVGA GPU architecture. Otherwise 24 gigabyte of video RAM is not enough. So hopefully Nvidia is watching this video and they're gonna do that. And or maybe it's going to be as again RTX 4090 Ti video card, but Nvidia, please equip it with 48 gigabyte of video RAM, otherwise we're not going to explore fully EVGA GPU architecture, and EVGA GPU architecture should be explored under 16K video resolution when every single CUDA core will be utilized. And RTX 4090 video card has 16,364 CUDA cores. it more CUDA cores that my width in terms of the pixels, because in terms of the pixels right now I'm using 15,360 pixels, but EVGA GPU architecture, which is in RTX 4090 video card, featuring 16,364 CUDA cores, more CUDA cores than I'm featuring pixels in terms of the width. So you can imagine what kind of power it is, guys, especially levels, second level or level second cache, properly level second cache on that GPU will be 72 megabytes. It's 12 times higher than on Turing GPU architecture, and level second cache on the RTX 4090 video card is 4 terabytes per second, 4.9, and some tests show 6 terabytes per second under the micro benchmark using the CUDA by the Nvidia, while the Titan RTX level second cache is only 1.7, 1.8 terabytes per second, while the video RAM bandwidth on the Titan RTX, as you saw, 679 gigabytes per second, while the overclock 790 gigabytes per second, while the level second cache 1.8 terabytes per second. And so pretty much level second cache is at least 4 times faster than the video RAM. This is by the rule of the Nvidia. It's from 3-6 times, because RTX 4090 video card is almost 6 times faster level second cache on the GPU versus the video RAM. And Nvidia using two levels of the pre-caching, which is level first cache, level second cache. Level first cache is split on the streaming microprocessor units, and each streaming microprocessor unit has same amount of the CUDA cores, is split it into the blocks, and they utilizing the level 1 cache per every single streaming multiprocessor block or unit, and those CUDA cores in those blocks utilizing that level first cache shared, while the level second cache shared on all the streaming multiprocessors, on all the CUDA cores. So the more shader cores, CUDA cores, shader cores, no matter how you're going to call it, Nvidia call them CUDA cores, on their pipeline GPU design. So the higher level second cache you have, the better, guys, and it's faster as well. Okay, makes sense. I think RTX 1590 video card will show here, guys, 60 FPS playable at the low preset 16K video resolution, the next generation after the EVGA. But 24 gigabyte of VRAM will be more than enough for the Metro last light to play it without the VRAM overload. But of course 48 gigabyte will show a little bit faster performances, will be better. The DirectX 11 API will feel a little bit better and comfortable, because when the video RAM utilization reaching above 20 gigabytes or 20,000 megabytes, the DirectX 11 API and Nvidia drivers is predicting and start offloading already some data even without reaching the full capacity of the load on the video RAM. It's already predicting, because it doesn't want to crash the game. It doesn't know when the doesn't know of the future loads. So if it see the game's loading a lot of data and it's already over 20 gigabytes of video RAM utilization, it's starting offloading some data into the system RAM. I believe it's based on the Nvidia driver, based on percentage of the load and how much data is loading per second, and it's predicting based on those values. This is how I would do it as a game developer, software developer. Anyways, medium preset, great FPS. As you can see, it's almost lower by 2 FPS from low to medium. Great result, great performance out of the Turing GPU architecture. The level of details is unbelievable, and this is the still medium preset, but it looks like a very high preset on 4K resolution already, guys. And this is without the tessellation. Tessellation will even modify the 3D meshes to another level. It's going to bring more polygons to it, and texture will fit much better on the 3D meshes, 3D models. Still, video RAM utilization below 11 gigabytes or below 11,000 megabytes. So guys, I tested this game in 4K resolution and 8K video resolution with everything is healthy. FPS was way above 30 FPS average, healthy FPS, and the system RAM utilization doesn't switch when you switch in between the low all the way to very high. Keep that in mind, it's going to be the same system RAM, almost the same system RAM utilization. So when you're gonna see a big jump in system RAM utilization at the left top corner, as again, this is going to be a clear sign video RAM offload. Even if we're not reaching the 24,000 megabytes on our video RAM, if it's going to be like 22,000 megabytes, the driver is already predicting. It's afraid that it's going to overload and it's offloading next data into the system RAM. Okay. And I'm sipping the hot chocolate, Swiss chocolate with the coffee, guys. Outside it's windy and snowy. I just woke up. Before eating, I just went outside. I walked a little bit, breathed that clean air, and receive that dose of the fresh snow outside. And I decided to go ahead and jump in and do the first Metro Last Light 16K video resolution benchmark for you guys. So don't forget to smash that like button. A lot of time, money, energy, guys, invested, and all what I'm asking for you to smash that like button, share it with your friends, subscribe, positive comments, and yeah, it's going to be a great ride over the UHDking.com. Not only we're going to test the games, we're going to develop the games. And there's going to be a great IT channel, guys. If you're PC hardware enthusiast, PC overclocker, software developer, game developer, or even gamer or graphics designer, 3D artist, I'm going to provide a lot of value in terms of those industries over the UHDking.com, and you're going to learn a lot of information, a lot of tips, and a lot of experience will be shared. The game looks absolutely amazing, guys, under the 16K video resolution. Of course, it's running like a frame rate, unfortunately, but as again, this is the world's first video card that is allowing us to do it. And you need to have at least 24 gigabyte of video RAM if we are talking Nvidia GPU architecture and Nvidia video cards. When we are talking AMD video cards, AMD is using less of video RAM than Nvidia because AMD went through a different GPU architecture. They're using level 1, level 2, and sometimes even level 3 cache, while Nvidia is always using level 1 and level 2. They're not using the level 3 cache yet. So after the level 2nd cache on Nvidia, it's a video RAM, which is the slowest memory for the GPU to pre-cache, and then the system RAM. So Nvidia using the fastest memory will be a level 1 cache, then it's going to be level 2nd cache that will be off of the streaming multiprocessor units, but it's still going to be on the GPU. But it's going to be shared with all the streaming processor units, while the level 1st cache, as again, is shared with each streaming processor unit. So it's allocated per each streaming processor unit to its individual CUDA cores on that only streaming processor unit, while the level 2nd cache on all the CUDA cores and all streaming processor units, and video RAM on all the CUDA cores and all the streaming processor units. But GDDR6 by Samsung and Titan RTX is still very fast video RAM with almost 700 gigabytes per second bandwidth running stock, and when it's overclocked, almost 800 gigabytes per second bandwidth. It's amazing, guys. Great value, but as again, you're going to see when I'm going to switch to a high preset, it's not going to be fast enough to pre-cache the data in real time, because the Metro PC game, Metro 2033 PC game, Metro 2033 Redux PC game, Metro Last Light PC game, Metro Last Light Redux PC game, and Metro Exodus PC game, pretty much the for a game engine is pre-caching some data at, I believe, at some radius when the game is running in real time, and that pre-caching after 8K resolution takes a lot of, guys, GPU performance power, and Turing GPU architecture is not fast enough to pre-cache it in real time. We're going to see if RTX 4090 video card will be fast enough to pre-cache that, and the components will be, as again, the level 1st cache, level 2nd cache, video RAM speed. This is how fast they are, how much bandwidth they can push, and it's going to decrease the time of the pre-caching, and we're not going to see that pre-caching when it's going to bake the texture from different maps into the final texture. You're going to see it a lot when I'm going to switch to high preset. After this medium preset, we're going to switch to high preset, and you're going to see a lot. Actually, I think this is running right now high preset, and you saw when it started from the first benchmark, from the first test under the high preset. This is the high preset right now. It was pre-baking some textures, some maps into the final textures. You saw it. So that means that GPU is not fast enough, and I think it's level 1 cache, level 2 cache, and video RAM. The whole GPU pipeline is not fast enough to pre-cache it in 16K video resolution in real time. And after it's pre-cache all the shaders necessary that needs to be pre-cached, then it's running second and third benchmark already with pre-cache, and textures is already pre-baked. It's pre-baked kind of techniques for the game developers called. And you saw how it was building through the maps the final texture. You saw that texture was not ready, and then it's building more details, and you see how the details pop up. So pretty much it was pre-baking kind of shaders using this game engine, and this is how it does for this particular game engine. Every single game engine has a different approach towards the 3D rendering, but pretty much it's just like overlay. It's still using the same API, and but a little bit different approaches. Some game engine will be faster, some game engine will be slower, and some game engine will be totally garbage. It depends, you know, what kind of developers was developing it and what kind of visions they had in the future. But proper game engine is going to be just like a soft overlay, just like this one. And this is great game engine. Look at this, the visuals just unbelievable. The level of details, 132.7 megapixels. And I'm about to, guys, to pause the game. I learned how to pause the benchmark on very high. We're gonna do it on very high with the tessellation very high benchmark. We're gonna pause, and I'm going to use the Windows magnifier tool. I'm going to zoom in, and we're going to compare the pixels for those people that are trying to compare the pixels. But as again, you don't want to compare the pixels on a video, because video using some video encoding and it's blurring out some pixels. But we're going to compare it under the zoom tool. Is going to be the best way to compare it. Okay, even if I'm recording in 8K resolution and 100 megabytes per second bandwidth, it's still going to use that blur through the video encoding while recording, and plus additional blur will be applied through the video encoding by the YouTube. It's going to be done organically, not even artificially. Gonna blur out some pixels between each frames. So you don't want to compare the pixels throughout the video, keep that in mind. Only throughout the uncompressed screenshots. But I'm going to use the zoom tool, and it's going to be obvious for us. Under 1600%, 1000% zoom tool, we're going to see those pixels much better. And this is exactly, maybe will be the scenario for those folks that like to compare the pixels. So don't forget to smash that like button when we can compare the pixels actually, okay? And when you're going to see the benefits of 16K video resolution. But pretty much the benefits of above 8K video resolution or 8K resolution versus 1080p and 4K resolution will be when everything will be rendered, even at the longer radius. When you're using 4K resolution 1080p, those details will be blurred out organically, even if you're not using depth of field, due that the distance and amount of the pixels capable to render in real time, and the lower resolution, because not enough resolution to render those details of those textures on those 3D models. But the higher resolution will render much higher details at the longer distance, more details, and overall it will bring that more realism and more kind of fakeish visual experience, like it's better visuals, but it's just more pixels, but it's still for your eye, it's going to psychological effect. It's also for me as a 3D artist, it's giving me that effect, like the 3D models, 3D meshes also having more polygons into them, but it's not, it's just psychological feeling, because as a raster it's rendering more pixels to it. Hopefully, as a final result, it's just the same output, even if the 3D meshes will have higher polygons, but it's not. But as a final result, it's generating as a raster image like that. And maybe it's not even psychological effect, maybe it's a mathematical effect as a final result. But guys, there is benefits, only pros and benefits when you're talking 8K resolution and above. It's just unbelievable. And 16K video resolution is the maximum resolution, and in the end of this video I'm going to prove it to you why. So keep that in mind. Stick around till the end of this video when I'm going to provide some more tips about my PC configuration. If you're building the used system from the Titan RTX video card, you always want to build with only 2 Titan RTXs and SLI. Otherwise, build it with a single RTX 2080 Ti, because single RTX 2080 Ti pretty much the same video card. I own both. 2 Titan RTXs and SLI and 2 RTX 2080 Ti and SLI. Same video cards. If you're playing 4K resolution, old school games before 2020, you want to have RTX 2080 Ti. You will have enough video RAM, which is 11 GB, and great FPS, like 60 and above FPS average for sure in 4K resolution. But if you're playing above 4K resolution, you want to have Titan RTX, and do not get one, because your performance will be the same as RTX 2080 Ti video card GPU, because the GPU is almost the same as TU102 that is featuring in Titan RTX video card. It's only going to be 256 CUDA core less. But when you're using SLI, you have advantage of 512 CUDA cores and 2 Titan RTXs. And 512 CUDA cores during GPU architecture is pretty much a great advantage, guys. Believe me, it's like a Kepler flagship video card. Okay, the difference. And just that SLI, pretty much the same GPU, but in SLI, 2 Titan RTXs will outperform 2 RTX 2080 Ti and SLI by a lot. Keep that in mind, because 512 CUDA cores, 256 times 2, because each Titan RTX has advantage 256 CUDA cores during GPU architecture versus the RTX 2080 Ti. So you want to build from 2 Titan RTX use system only if you're playing above 4K resolution, and 8K resolution will be Gucci, because a lot of games at 8K resolution utilizing 99% of the GPU, but only an SLI in the games DirectX 9, DirectX 10, and DirectX 11 API. DirectX 12 API doesn't support SLI. That means newer games not going to support SLI, because nobody going to use for the newer games DirectX 9 or DirectX 11 API. They're using DirectX 12 API. Hopefully, guys, this makes sense. They as game developers, okay? Beautiful visuals. This is a very high preset. The FPS is 6 FPS average. The video RAM is still below 16,000 megabytes, below 16 gigabytes. So video card with 16 gigabytes still can render this when it comes to Nvidia video cards, but AMD video cards will probably use like 11 or 12 gigabytes. They're using a little bit less RAM because they're using better texture compression, guys, through the hardware than Nvidia. Keep that in mind. On that level of technology, AMD is better than Nvidia. So that's why they're utilizing less video RAM than Nvidia video cards. Hopefully, guys, this makes sense. The system RAM is increased by a little bit, by about 300 megabytes, but still below 11,000 megabytes of our system RAM utilization, which is below 11 gigabytes. As again, Titan RTX is overclocked to the maximum possible safest scenario, running on dual fan Nvidia air cooler, but GPU is on the liquid metal thermal paste by Thermal Grizzly, and thermal paste on the video RAM, which is also high-end. So that's why, but I'm not advising you to do that, guys. It could be unsafe if you're not a professional hardware enthusiast to repaste that liquid metal, and liquid metal is good only for 2 years, and then it disappears, evaporates, and you gotta repaste it. Keep that in mind. So just better stick with the stock. Do not do any replacements. It guys, doesn't worth it. You can only improve in terms of the video RAM overclock by 600 megahertz additional, but it's maximum gonna bring 1-2 FPS maximum. But you gotta repaste every 2 years, paste, and if you're not professional PC hardware enthusiast, if you didn't repaste video cards before, maybe you can even kill your video card. So just keep it alone. Titan RTX or RTX 2080 Ti. Repasting maximum gonna give you 1 FPS, but it's risky, and that paste, expensive paste that you're gonna use, you're gonna waste $20. Doesn't worth it. Okay. Use MS Afterburner through the software and overclock it on the stock thermal compound paste. You will be Gucci. Do not push it too hard. Do not push it when you're gonna see the artifacts, because otherwise you can burn out your video card if you're gonna run like this for a couple hours. That's why people destroy their RTX 2080 Ti video cards, GTX 1080 Ti video cards, because they're pushing them pretty hard and was running hours in the games with the software overclock. Software overclock is safe, but do not push it to the maximum. Just push it 10% and leave it like that. 10% you will be safe under the software overclock. And software overclock bringing you 7-10%, and this is safe. This is allocated for you by the manufacturer just as safe margin, so they're not pushing their technology to the maximum. And but you can still overclock at 10% and receive the 10% boost, and it's going to be safe. It's still safe. Anyways, guys, 6 FPS average, sometimes jumping to 9. Cannot wait to test it on 2 Titan RTXs in SLI, but not playable, but still benchable in real time. And we are here to see if it's runnable at least. And it's runnable, yes, and benchable in real time as well. Great result. Nvidia is magicians. Their engineers are pretty much geniuses. Jensen Huang is one of the best human beings for any gamer on the planet Earth. Look at this. AMD is at least 2 years behind. I just want to let you know, guys, there is no such a technology that AMD can produce in real time, this type of FPS in real time in this game. Because they're not going to feature enough video RAM, or they're going to have feature enough video RAM, but they're not going to have enough of the GPU performance to run it. I mean, there is AMD video cards that is faster than Titan RTX in 2022, yes, such as RX 7000 series, Radeon's RX 7000 series, but they not going to be as fast as the EVGA GPU architecture. Keep that in mind. It's going to be fast as a pure GPU architecture such as RTX 3090, not even RTX 3090 Ti. It's going to be hairs faster or hairs slower than RTX 3090. Okay, not even 2 times over the Turing GPU architecture. So AMD right now in 2022 can outperform this technology, which is Turing GPU architecture, in 2022 on the 16K video resolution. But as again in 2022, and Turing GPU architecture was available to us in 2018. So today you're watching in 2022 the technology that was available to us in 2018. Because I purchased Titan RTX in 2019, but Titan RTX was available for sale in the end of 2018. Keep that in mind. 2 Titan RTX's video cards in SLI will outperform AMD Radeon RX 7000 flagship video card. Please keep that in mind. Which is 7900 XTX. So pretty much AMD is still behind even in 2022, because 2 Titan RTXs in SLI outperforming from 2018 that AMD Radeon RX 7900 XTX video card, which is the flagship video card in 2022 from AMD. Alright, great results. I believe this is very high preset without the tessellation. We are about to find out, but this is actually will be with tessellation on normal, or still without tessellation. We're going to find out in a few seconds, guys, when it's going to be done, and I'm going to use the zoom tool to find out in the browser. Too bad the game developers didn't think it through. When you're running multiple benchmarks, it's collecting the data and displaying in the browser when the next benchmark starts, and it's creating that extra delay. If you're a game developer, you want to make sure that you're loading this data in the end, so you're not stressing the next benchmark that's coming out. Okay, so when you're developing games, you always want to think future all the time, future. The 4A games developers did a better job than the Stalker game developers, GSC Games from Ukraine. Both studios from Ukraine, they did a better job. So it was what, very high. Advanced physics was disabled. Tessellation was normal. It was with normal tessellation, and it crashed after first test or during the first test, and it didn't crash while I didn't record with Nvidia ShadowPlay. So it's using the same look like components as Nvidia ShadowPlay, and it's crashed. Let's try rebench it one more time. If it's going to crash it again, maybe it crashed because I was moving my mouse. Let me go ahead and close it. So it was under the normal. Let's go ahead and rebench it again. Distillation. But let me go ahead and try it again. Maybe just because I'm recording with Nvidia ShadowPlay, it cannot do it. And the Metra for a game engine show that it's kind of using the same components as Nvidia ShadowPlay using in real time. So while you're recording with Nvidia ShadowPlay, it's stressing the video card to another level while you're not recording. And I'm going to demonstrate it to you guys in a second. Anyways, so the preset was this one right here. This was the test. Let's go ahead and run it again. Let me actually, I'm going to disable those, and we will try to run it again. 1 second, guys. Make sure I'm going to delete ones that we don't need. Okay, so very high. Without distillation, we did it completely, and this is at normal. So this is where we stuck. Let me go ahead and rebench it. I'm going to run it all. The soundtrack and the background is all right reserved, provided by the YouTube. It will be at the foot of the Sphinx by Twin Musicom, as you can see. And as again, it's all right reserved. No royalties can be claimed, provided by YouTube. So it's gonna tell us, all right, so do you want to run it? It's gonna take some time. I'm gonna say yes, let's do this. It's gonna run it. And just because it crashed, yes, the game engine crashed, it's gonna say, do you want to run safe mode, yes or no? I'm gonna say no, and we're gonna run just like benchmark did it. Let's go ahead and have a look, guys, if it's going to crash it or not. If it's going to crash it one more time, that means that the game engine is utilizing same components as Nvidia ShadowPlay utilizing, and its special chips on the video card. Because Nvidia ShadowPlay is accelerated by the software and hardware. The best video capture, guys, is the video capture software that is going to be accelerated by the hardware. And Nvidia ShadowPlay is the best video capture software out there in real time, that capturing your desktop or game at that motion blur at low, and unfortunately I cannot disable it under Metro last light. And it's ruining, as you can see, when your FPS below 10 FPS, everything is so blurry, because it's rendering one frame, and then second frame is blurring, and then next one is not blurred. And this is how it's through the post-processing effects, kind of through the game engine, is kind of creating that motion blur. But when you're recording on a video, you don't want to enable motion blur, because, as again, it's going to do it organically, motion blur, while it's going to do the video encoding of those frames through the video codec while you're recording, and then YouTube gonna do it again, and it's going to create that organic motion blur as well. And this motion blur in the game is created through the artificial motion blur within the algorithms by the game developers. Okay, the latency delay very high, above 100 milliseconds. The system RAM utilization is still below 11,000 megabytes, so healthy video RAM utilization. We're not uploading any data yet, or maybe uploading just a couple hundred megabytes that is not necessary from a video RAM into the system RAM. But just because the system RAM below 16,000 megabytes, I can state that we have a healthy VRAM utilization, so healthy FPS right here, out of the TU102 GPU by Nvidia or on a Titan RTX video card. So 16 GB of video RAM will be Gucci for the Nvidia video cards over here, guys. And this is very high preset with the tessellation at normal. So as again, what tessellation does, tessellation pretty much bring more polygons in the 3D world. So it's splitting the polygon into multiple polygons. It depends what kind of algorithm you're using, the developers. It could be 2 polygons. We can split one polygon into 2 polygons. So let's say if the 3D model, 3D mesh of the character is 50,000 polygons. If I'm using the tessellation 2x, it's going to be 100,000 polygons, same mesh. And what it does is pretty much define the 3D mesh, and it's fitting better texture, and these kind of squarish 3D objects becomes more like cylinder 3D objects. So you can create from the cube 3D mesh while using the tessellation. You can create a cylinder or you can create a sphere. Okay, so this why and how the tessellation is applied. If you're a game developer, or if you're a gamer, for you to understand, or if you're an artist, 3D artist, like let's say in 3ds Max. But in 3ds Max, you know exactly by how much you're tessellating your polygons, by 2x, 3x, 4x. But over here it's like presets, normal, high, and very high. So I'm not sure what kind of multiplier they're using for the tessellation, but we can assume that it's much heavier. The scenes become much heavier. It's rendering much heavier polygons per second, more polygons than used to without the tessellation. During GPU architecture and tessellation algorithms, no problem under the Metro 2033, Metro 2033 Redux, Metro LS Lite, and Metro LS Lite Redux, guys. No matter what kind of resolution you're using, maximum you're going to lose about a couple FPS. Not too much, 1-2 FPS throughout the enabling tessellation and disabling the tessellation, because the Turing GPU architecture is such a powerful GPU architecture, has 6 megabyte level second cache, and it has no problem to tessellate and load double amount of polygons without any issue. Polygons is not that issue for the Turing GPU architecture. The complex shader computation is what is stressing the Turing GPU architecture. But polygons is not an issue any longer for Turing GPU architecture, and it's not going to be an issue for the newer GPU architectures. Please keep that in mind. As again, to be able to run 5.3 gigahertz, I disabled 2 physical cores, disabled the hyper-threading technology, and as you can see, it's running 5300 megahertz and sometimes switching to 5200 megahertz because I'm running 52 multiplier for the EVGA instruction. And for the Intel 9000 series, it's switching from the external frequency to the EVGA instruction because it's always running lower frequency, and it's decided by the Intel driver. And when it's doing that, it means that Intel driver believes that we're not going to benefit with the higher frequency, so it's saving you some energy and lowering the temperature on the CPU while it's switching to the lower frequency. So it's kind of like a thermal throttling process, but it's not. It's based on different theories. While it's lowering the frequencies on your CPU while lowering the temperature, at the same time Intel driver believes that you're not going to benefit. That's why it's doing that. And there is no way for us to force it manually constantly to perform 5.3 gigahertz or 5300 megahertz. So this is the nature behavior for the Intel 9000 series CPU, which is the Coffee Lake, Intel Coffee Lake CPUs. Please keep that in mind. Okay, still below 16,000 megabytes. So I think it crashed because I was moving the mouse. I dropped actually the mouse. I touched it and I dropped it from the table. I think that's why it crashed. Thanks God that I rebanged that. As you can see, I'm taking all the intelligent approaches throughout my benchmark. So benchmark are so constant results and correct, and the proper value and data is provided to you guys. By the way, hopefully, I think YouTube AI in love with me, guys, and Google AI, because it's collecting right now so much data, and then it can build up its own graphs and its own results while comparing different technology by just studying the data from my YouTube channel. I think Google AI and YouTube AI is in love with me, guys. And I think Google AI and YouTube AI, I can build the charts in the future over the Google search engine to show you the comparison between the video cards, or utilize this technology on YouTube under the PC hardware reviews. Can using the AI, can collect the information throughout all the YouTube channels, analyze it, make sure it's correct information, and then build up from that information the charts by the AI. AI is capable to do it in seconds now in 2022. Hopefully Google will utilize this technology in YouTube. Okay, so 6-7 FPS average. So as you can see, tessellation no matter. This is the third benchmark. Tessellation normal, very high preset. And great results. So almost as good as Metro 2033 Classic or 2033 Redux, almost the same FPS, but in terms of the visuals, much better visuals. And the meshes in the characters, in those soldiers, much higher polygons count in them versus the Metro 2033 Classic. They're much more cylindric instead of squarish, and you can see it even without the tessellation. So pretty much, what is the tessellation? Tessellation is saving you the space instead of creating the low polygon model, high polygon model, and based on the preset and manipulate that, but it's gonna consume a lot of storage of the final game. It's using the preset and it automatically using the geometry increasing the polygons on any 3D mesh. So you don't need to upload or create as a game asset low polygon model and high polygon model. You can do just low polygon model and using the tessellation create low polygon model on the fly in real time into the high polygon model. So this is the advantages of the tessellation feature, and this feature was introduced to us on the DirectX 11 API as pre-built classes for any developers to use. So pretty much they're loading the mesh and they're saying, okay, tessellate it by this much time, and it's going to tessellate every single polygon. Is going to multiply, split it into multiple polygons as again and turn it at some level of degree. So it's going to create, instead of cubic, it's going to create cylindric, and that's why you this is how you're creating from a basic geometry into much more complex advanced geometry on the fly in real time using the tessellation methods as a feature of the DirectX 11 API, or some game developers can come up with their own, but over here you don't have to program. You can use the pre-built without any box classes that's going to split your polygon without any issue. Alright, so still below 16,000 megabytes, great video RAM utilization. System RAM utilization is 11,000 megabytes, which is 11 gigabytes. So we uploaded some data, probably like 400 megabytes, that's not necessary from a video RAM into the system RAM, decided by the game engine and Nvidia driver that it's not going to be that much, you know, a problem. Sometimes it's uploading like below 1 gigabyte in some games when it's not that biggie, even if you're not overloading your VRAM. Okay. So GPU utilization is great. We want to have GPU utilization 97% and above, like 100% is the best. It's like excellent GPU utilization. That means that we're utilizing every single streaming multiprocessor block or unit and every single CUDA core in them. So every single CUDA core right now on GPU is overall utilized at 100%, which is great. And CPU utilization we want to keep all the way below 90%. If you can see when it's reaching 90%, sometimes at some sort of seconds, that's a clear signal for you that you gotta add at least 2 threads. Otherwise, there is a possibility that you can bottleneck your FPS through the CPU threads. You need to have at least 2 more threads to go. The best way will be to add the physical core or physical cores. But in our case, we will never reach even 50% of our 6-core, 6-thread CPU. So I don't need to enable 2 more physical cores because we're not gonna increase FPS. You know, it's just going to be the same deal. Keep that in mind. we're only going to increase the latency delay. We're going to slow us down by a little bit by increasing our core count, because the CPU kernel is checking, okay, how many cores are available, how many cores are loaded, by how many percent. So the more cores, the more milliseconds it will take to check it. It's not milliseconds, it's nanoseconds, but anyways, it's creating the latency delay. Hopefully, guys, this makes sense. Beautiful, beautiful test. Let me reload some coffee, guys. I'll be right back. Keep your eye at the left top corner right now. I'll be right back in a few seconds. Alright, guys, I'm back. You can hear that I'm sipping some hot chocolate, hot chocolate and coffee. Healthy drink. Much better than drinking soda with artificial sugar. Okay. Mostly it's running 5.2 gigahertz because it's using a lot of AVX2 instruction throughout the game engine. So game engine is utilizing AVX2 instruction, and AVX2 instruction is much faster than external frequency. Keep that in mind when it comes to Intel 9000 series. That AVX2 instruction is accelerated with some algorithms, and it's when you're comparing the frequencies of the AVX2 instruction versus external frequency when supported as AVX2 instruction computing, AVX2 instruction will always outperform external frequency on Intel 9000 series CPU. That's why it's using the fastest type of scenario decided by the Intel driver, and it's utilizing the AVX2 instruction. If I would keep my AVX2 instruction as default 37 multiplier by the Intel, or 47 multiplier, I believe by the Intel is by default, it would be running 4.7 gigahertz. But as you can see, my AVX2 instructions is always overclocked to 5200 megahertz, and the cache frequency is also 48 multiplier. It's decreased the latency delay between the system RAM and the CPU. I'm running like this setup over 2 years. It's stable, no problems. The voltage very high, 1.475. When I'm playing the games with 6 core, 6 threads at 5.3 GHz as external frequency and 5.2 GHz as MX2 frequency over 2 years already, no problem. With this high voltage, I know for some people this voltage is too high. Those people doesn't know what is the overclocking and they're panicking and never overclock the video cards, misleading with their misinformation. Some folks that trying to overclock and but it's no problem. 1.475 volts, guys, as you can see, no problem. Running like this for 2 years, like 24/7 every day, playing games and such, video encoding, it's no problem. Okay, so right now it's using, I'm gonna pause, but not right now. We're gonna pause on the third benchmark. We're gonna find out what we're using. At the same time, I'm gonna pause on the third benchmark, and I'm going to use the Windows magnifier tool. For those people who's comparing the pixels, is going to be a great level of comparison under the 1600% of the zoom, which will be crazy, and you're gonna see how clean everything will be. I'm gonna just demonstrate as a fact that we're running 16K video resolution natively rendered on the third, not on the first one, but on the third. By the way, Metro Last Light Game Engine is preloading the pre-caching the shaders much faster than Metro 2033 Redux or Metro 2033 Classic PC game, at least throughout the benchmark. It's a little bit faster on tuning GPU architectures, pre-baking the textures from the maps into the final textures much faster when compared to 16K video resolution tuning GPU architecture and the Metro 2033 PC game or 2033 Redux. The game looks absolutely amazing, guys. 16K video resolution, this is unbelievable. Advise you to play it like this in 8K video resolution or above, like 16K video resolution, even with DSR. I can see a big difference when I'm doing this task 8K native and outputting to my 8K native screen, or when I'm doing this 16K DSR and outputting to 8K native. I can see the difference, guys. 16K DSR is just unbelievable, even when compared to 8K native and output to 8K native versus 16K DSR and output to 8K native. I can see the difference, guys. But make sure that you have above 60 inches screen to be able to see the difference. So this is the second benchmark. We will wait till the third one. As you can see, data is already pre-cached, the shaders. So it's not pre-baking any more textures. It's already here, ready. I'm going to do two different videos, guys. I'm going to do benchmark, and then I'm going to do the gameplay for every single game on tuning GPU architecture. So for those people who's curious to see the gameplay will be available in 16K video resolution in Metro 2033, Metro 2033 Redux, Metro Last Light, and Metro Last Light Redux. But pretty much it's just the same deal, guys, as in a benchmark. Plus minus 3 FPS difference. But just for those who's curious, I'm going to show you the gameplay. But the scenario pretty much going to be the same. It's just for the naysayers, just as a fact. So I'm going to use it as a proof over my YouTube channel in any arguments. And you can use it as well, by the way. So as you can see, when we increase the tessellation, we increase a little bit of the system RAM usage by, I would say, 600 megabytes extra. Gosh, everything is just beautiful. The motion blur at low pretty much ruined the visuals because the low FPS, but the level of details is unbelievable, guys. Okay, so this is the second, and when we're gonna move to third, I'm gonna share you the third under the magnifier tool, zoom tool by Microsoft. Look at this, the CPU performance will be below 40%, not even 50%, not even a second. I said 50% CPU utilization. That means that we're like utilizing below 3 cores. And as you can see, we're utilizing them evenly, so it's great multi-core utilization, but very low usage per core per thread. Right there, the left top corner. The GPU utilization in terms of the wattage will be above 300 watts when the Titan RTX video card is overclocked. Otherwise, it's going to be below 300 watts. Okay, it's going to be the third. Now we're gonna, here we go, the third benchmark. Now I'm going to use the zoom tool. Let me go ahead and use it. Hopefully it's not going to crash. Yep, we're gonna bring that. Let me see what kind of, as you can see, it's paused the game when I brought it. And I'm running in windowed mode as again Metro Last Light or Metro Last Light Redux or Metro 2033 or Metro 2033 Redux under 16K video resolution, flickering some shadows on the full screen. So run it in windowed mode if you want to benchmark it for the proper result if you're trying to compare. And this was, guys, on a very high AF16X. Physics was disabled, but the tessellation was high, so not very high. SSAA off, because SSAA is not possible even without the recording. So let me use the zoom tool, and we're gonna use the zoom tool. Let me show you. The texture is pre-baked. Let me show you the level. This is the motion blur, so as you can see, the pixels is a little bit blurred out. Let me see if we can. 1 second, guys. Let me see if we can go and receive a better result in terms of the pixel rendering. So I'm gonna go here. Let me see. I'm going to get back into benchmark. And then I'm gonna. Here we go. This is with the blur, unfortunately, but you can see the level of the pixels. Let me. Still blurred out, huh? Yeah, it's. So you can see they're using per frame. Yeah, because the FPS is low. But the yeah, I guess we cannot compare the level of details like that. When I'm stopping, it's using the blurred out. Maybe here we go. Almost. It's blurred, but still look. This is going to be 600% zoom. 600%. Okay. Check it out. So 16K video resolution rendered in real time. This is 1100. Let me put 1600%. So this will be, this portion of the screen will be 4K resolution, because 16 4K resolution screens is equal 16K UHD or 16K video resolution. And yeah, look at this, the level of detail right here on the texture, like those dots and such. This is the level of detail, like a dirt on his mask. You're not gonna see it, guys, on 4K resolution. It's just going to be blurred out completely if you're gonna run the game in 4K resolution. And if you're gonna use 16% zoom and you're gonna zoom in into 4K resolution, everything over here will be blurred. All those textures will be blurred, completely blurred. You're not gonna see those details, the dirt and such. It's going to be like this on 4K resolution, even without the blur, but over here, the level of details. It's just going to use out of the 2 pixels, I'm gonna make 1 pixel blurred out because not enough resolution. Because this face, the whole face and the whole model, probably at least 2K video resolution texture. So to be able to run this model and 3D Mesh completely load all the texture details, you need to, that model needs to be at least 2K resolution pixels. And it's not going to be, if you're going to run at 4K resolution, it's going to be like maybe 500 by 200 pixels at that distance. Let me. Alright, let me use the zoom tool, guys. Zoom out, and we're going to finish the benchmark. Let me use the zoom tool right there. Look at this, that level of detail is right there. Let me show you something. Still blurred out through the zoom. Too bad that we cannot disable the zoom, but if you're going to run 30 FPS or above with blur tool, everything will be nice. But check it out, the level of details. This is just, and this is at the very high distance. So that distance, let me zoom out. That soldier right there, if you're running 4K resolution, it's probably going to be like 400 pixels by 200 pixels. Or 400 pixels by 150 pixels, the whole soldier. So if the texture is 2K resolution or even 1000 resolution of that soldier on that 3D mesh, you're not going to render even the 50% of the details of the texture. Hopefully guys this makes sense. So I just explained to you the benefits of the 16K video resolution or 8K resolution or anything above that resolution. Hold on 1 second, let me turn on the magnifier. Here we go. Beautiful, just beautiful level of details. Of course it's blurred out because the lower FPS, as I explained to you, but if it's going to be 30 FPS, it's going to look just like eye candy, guys. Yeah, 132.7 megapixels is not a joke. That means that we're rendering every single detail out of those textures if the texture is below 4K resolution. But if the texture is only 4K resolution, even under 16K resolution at that distance, we're not going to render the full details of the texture. Keep that in mind. Under the 16K resolution, if the texture per 3D model is 4K, but I think it's 2K. So if the texture 2K at the distance, we're rendering, guys, full level of detail of the texture. And you can see how everything is detailed and sharp and beautiful. Yeah, this is just unbelievable performance. So RTX 4090 video card, I don't think it's going to deliver here, guys, 30 FPS average. Even if RTX 4090 video card is 3 times as minimum faster than Titan RTX video card, it's going to be around 16 maximum FPS, I think, over here. Maximum 20, but not even above 20 FPS. And it's still going to be a great result. I think when RTX 4090 video card will be utilized at 100%, I think it's going to be at least as minimum 3.8 times faster than Titan RTX video card. But we're going to find out. I cannot wait to test it as again. This is what I thought I saw after analysis from my friends' computers when I saw the test. Same test in 4K resolution or 8K resolution comparing to my system with the Titan RTX. It's at least, guys, 3.3 times faster. And in 4K resolution, when the GPU is not utilized at 100%, keep that in mind. It's crucial to utilize the GPU at 100% to be able to utilize the EVGA GPU architecture in RTX 4090 video card to the maximum potential. Alright, I think it's crashed or something happened. Let's go ahead and investigate what happened there. No, it's still running. We're still running. So we just did the very high preset AF16X. Physics was disabled, but distillation was very high. So the next thing will be physics enabled. So this is right now running physics enabled test, and physics enabled test will use the higher level of details in terms of the debris generated, and every single debris may have a physics into them, collision and such. Every single piece, particles in smoke and such, well, when you're using the advanced physics acceleration. But Titan RTX video card, since I believe in Maxwell GPU architecture, they have a special chip that required to have the advanced physics acceleration. It used to be was a requirements when you need to have additional video card by Nvidia to accelerate the physics, like in Fermi and Kepler GPU architecture. But like 4000 series GPU architecture, 5000, 6000 series, even 8000 series GPU architecture, even GTX 2600, GTX 400 series video cards. But it's not the case on the, since Titan X Maxwell GPU architecture, I believe But for sure, since Pascal GPU architecture, the previous GPU architecture when it comes to Turing GPU architecture, and Turing has no problem. So it has the chip on the video card that accelerating the advanced physics. As you can see in terms of the FPS, not such a big difference, almost the same FPS, plus minus maybe 1 FPS as a maximum. But the level of details in the game is amazing, and you want to play with advanced physics, guys, for the best possible performance. And I tested with that type of preset just in case. Beautiful level of details. The post-production effects in the 4A game engine is just unbelievable, guys. It's like so photorealism into it, but unfortunately the textures was cartoonish. That's why it's looking like a cartoon instead of photorealism. But if they would use the proper colors and such, if you're gonna bring this game into black and white mode, it's going to look almost like a photorealistic, guys. You can see it's looking cartoonish because it's using the cartoonish color gamma. Still 16,000 megabytes, below 16,000 megabytes. So I would say 16 gigabytes of video card will be good enough for the Nvidia technology video cards, and for the AMD technology video cards, I would say 12 gigabytes will be Gucci here. Because as again, they using better texture compression algorithms, accelerate through the hardware and software, and using less video RAM on the AMD video cards versus the Nvidia video cards. So this is going to be the last test with advanced physics. So pretty much Metro less light PC game utilizing less video RAM than Metro 2033 classic PC game or Metro 23 Redux PC game. This is a great achievement while delivering better visuals, better graphics. Great achievement by the 4A games developers. Did a good job. Every single game in Metro series is just piece of an art, guys. So excellent GPU utilization, 100%, and CPU utilization even not reaching 40%. Not a second as I saw. That's just unbelievable performance, guys, of the game engine. So it's utilizing, as you can see, properly the video card, which is it should in PC games, because the video card is much faster than CPU, which is GPU is much faster than CPU at least by 10 times, and video RAM is faster than system RAM at least by 10 times as well, as I prove it to you and explain to you why throughout this video already. Wow. Alright. Great performance for sure. So to run Metro less light in 16K video resolution, I would say you need to have at least RTX 5090. If you're trying to reach like 45 or 60 FPS average. Because I don't think that RTX 4090 will reach even above 20 FPS. But as again, on very high preset. I think it's going to be around 1820 FPS, very high preset on RTX 4090 video card. This is my prediction, but as again, we're going to find out over the UHDking a couple months when I'm going to benchmark RTX 4090 video card completely, guys, under 8K, 12K, 10K, and 16K video resolution, as well as I'm going to benchmark Metro series PC games in 8K, 4K, 10K, 12K, and 16K video resolution, so we can compare with the previous benchmarks that I did on 4 Titan X Maxwell GPU architecture in SLI, 290 in Crossfire, 2 Radeon Pro Duo with 4 Fuji XT GPUs in Crossfire, 2 GTX 1080 Ti and SLI. I also did like 8K, 10K, available over the UHDking.com to compare and see what's up. Yeah, running great. The performance just wow. Maximum visuals, guys. 16K video resolution, 132.7 megapixels rendered in real time, 6 FPS. That means right now we're rendering like 800 megapixels per second, which is almost 1 gigapixel per second, because 6 frames per second, 132.7 megapixels. Unbelievable. Great visuals. Visuals just like, oh wow. Cinematic right here. It's completely like a Pixar, guys, visuals. Yeah, that CUDA cores, 16,364 CUDA cores. Nvidia just pretty much aim at 16K video resolution and saying, look, 16K video resolution, the maximum amount of pixels 4:3 aspect ratio is 16,364 pixels. And we are featuring CUDA cores, not an even flagship of the EVGA GPU architecture, 16,364 pixels. And UHDking is the first YouTuber that's going to test it, not under the 16K divided by 9 aspect ratio 16K video resolution UHD, but I'm going to test actually under the maximum 16K video resolution supported by DirectX 11 API, which will be 16,364 pixels by we're gonna find out by how much, I forgot, but it's going to be a different aspect ratio. It's not going to be 16 divided by 9 aspect ratio as I'm running right now. It's going to be a little bit more pixels, but it's going to be amount of the pixels and width as much as EVGA GPU architecture in RTX 4090 video cores featuring on its CUDA cores on the GPU. And the full EVGA GPU architecture is actually above 18,000 CUDA cores, not 16,000, but above 18,000 CUDA cores. So the full ED102 GPU is actually featuring amount of CUDA cores same as Titan X Maxwell, guys. But as again, this is the newer version of the CUDA cores, much advanced CUDA cores featuring more level 1 cache per streaming multiprocessor units per each CUDA core, and more level 2 cache and level 1 cache on those CUDA cores. So, and more video RAM. No, kind of same video RAM, but faster video RAM with a faster bandwidth, GDR6X versus GDR6. So more bandwidth can push. So right now it's running, I believe it's running the with the advanced physics on. This is the last test with the advanced physics on, if I'm not mistaken. And it's going to be the last test. Oh, no. The FPS is high. This is not the advanced physics on. This is going to be the last test. It's going to be the low preset, but I using the advanced physics on, yes, and the distillation very high, but low preset, low visual preset, just to demonstrate for those who's curious when we're using some CPU and GPU in premix. So low preset pretty much is like CPU performance, medium preset like premix CPU and GPU, very high is purely GPU performance benchmark, and right now it's kind of best premix of the CPU and GPU performance at the lowest preset, but still with some GPU features that stressing our GPU as well, which is distillation very high and advanced physics on. Great FPS, guys. And this low preset with the advanced physics on, distillation very high, pretty much looking like a very high preset on the 4K resolution for sure. So I cannot as minimum. It's looking so clear, so nice, as you can see. And I'm probably going to pause here at the low preset. I'm going to demonstrate for you as again magnifier tool as again just one more time, but without the motion blur, so it's going to be a sharp pixels. You're going to see how beautiful pixels are in the 16K video resolution without the blur. Even with the low preset, it's going to dominate the very high at 4K. Due to that amount of pixels, as again, just because that amount of pixels. Yeah, 16 gigabytes for Metro Last Light original game is enough. 16K video resolution, this is impressive. Less than Metro 2033 and Metro 2033 Redux, with much newer game engine that right now the Metro Last Light PC game using. But as you can see, the whole game Metro Last Light was better design game, overall performance, and the better looking game as well. They did a good job. Good job. But Metro Last Light almost delivered the same FPS as Metro Exodus. Almost the same FPS. While Metro Exodus running 2 Titan RTXs and SLI though, keep that in mind. Versus Metro Last Light running single Titan RTX. The Metro Exodus, guys, is on another level. It's just the visuals is just great. 3D meshes in terms of the polygons, probably at least 4 times more. But I would say at least 2 times more in terms of the polygons from the start. When we're going to compare mesh per mesh in terms of the characters, for sure. And much better shaders use the Metro Exodus versus the Last Light. But Last Light, I remember when they introduced the game, it was looking so like on another level. Like I never saw something like this before. It was looking like completely Pixar cartoon or something like that. While you playing the game actually, which is much better. Okay, after this test on the third one, we're going to use the magnifier tool, and even as again at the low preset, they're not using all amount of pixels, but I'm gonna show you how great it's looking on the 16K video resolution low preset. Yeah, just wow. Guys, I'm losing my voice today. I already recorded 2 videos, and it's removing some noise from my voice, probably distorted as well. My voice is a little bit different sounding when I'm using the artificial intelligence that's removing the noise, fan noise from my voice. So you're gonna hear that fan noise like an airplane. Yeah, the FPS should be like above 30 FPS average over here with 2 Titan RTXs and SLI, but we're going to find out. Pretty much the same performance will be on RTX 3090 Ti, about 2 times more FPS. RTX 3090 Ti video card is 2x versus the single Titan RTX video card, but single RTX 3090 video card is 1.75, 1.8 times faster than single Titan RTX video card. 2 Titan RTXs in SLI will be faster than RTX 3090 video card in pure GPU architecture, but in pure GPU architecture, which is GA102 GPU, which featured in RTX 3090 Ti video card, the full GA102 GPU and pure GPU architecture will be 2x faster than single Titan RTX because it has 256 CUDA core more, and it has more streaming multiprocessor unit because more CUDA cores, making sense, and it's going to proceed a little bit faster by at least 10-12% faster than RTX 3090 running stock to stock when we're talking RTX 3090 Ti. So it's going to be 2x over here if you're going to try this on RTX 3090 Ti. But as again, this is my prediction. I didn't try it yet, and we're going to try it, and I'm going to share the benchmarks over the UHDking.com. Okay, let's go ahead and pause that. Let me use the zoom tool. Let's investigate some pixels under some crazy. 1 second. Here we go. Look how everything is so sharp. So check it out, guys. 1000% zoom in. We're zooming in. It's like in Photoshop when you're zooming in. Look how clear the pixels are. Yeah. 16K through 16K. Yep. So 1600%. This is the maximum zoom under the magnifier tool, under the 16K video resolution. So this is how it would be to upscale. If this would be rendered this amount of screen 4K resolution and upscale to 16K resolution, this is how it will look like. But with a 1600% zoom. But if you're not going to upscale, you're going to run 100%. And those details certainly there. Not a question. Alright, so we're finishing up, guys, and we're about to wrap it up. I'm so hungry. Gotta go ahead and grab something. And yeah, looking for your support. Metro Last Light Redux is coming in a few days. You don't want to miss. Check out the video comments, video description for more information. I'm gonna post more videos in the video comments with the future systems when we're going to test. So check out those videos for the comparison. Yeah, everything is such a solid. Check it out. This dude is like, the level of details, just like wow. Alright, almost there. 3 out of 3. Great performance for the first video card that is capable to run the game in 16K video resolution. It's just great. It's great for the screenshots. If you're trying to create some arts, running game in 16K video resolution, make a screenshot, load in Photoshop, and create some art, wallpapers or something like that. And as you can see, I was running the Metro Last Light PC game completely stock without any modes, but you can increase the visuals throughout some modes as well. So there is a lot of modding opportunity over here, as you can see. Great game engine, great speed, and yeah, running all like a soft overlay on a DirectX 11 API, almost without the limitations to the game engine. Okay, so this was the last test. Supposed to quit automatically. Let's see. Yep, it did. And I think we're gonna be done here. Yep. Let's go ahead and compare, guys, real quick. So this is without the recording, okay? So without the recording, 16K video resolution AF4X, low preset. So average 18 FPS. Let me show you within the recording. Let's go ahead and grab that right here. Within the recording, within Nvidia ShadowPlay, only 1 FPS difference. 17 FPS average. Check it out. 17, 17, 17. Okay, that's the difference. Okay, let's go through without the recording. For those who's curious, you saw within the recording, you saw the real data on the screen in the left top corner. This is within the recording, 16x low preset, 16K video resolution, low preset is again, everything else disabled, 18 FPS, great FPS. So 4x versus 16x, just like a Metro 2033 PC game, Metro 2033 Redux PC game under 16K video resolution, not even 1 FPS or maximum 1 FPS difference. For 2-inch GPU architecture, it's no problem. Anisotropic filtering for the textures, no problem at all. 16K video resolution, 16x, medium preset, 16 FPS average without the recording. And 7 FPS average, high preset without the recording. Okay, press pause, guys. I'm gonna go real quick through that, so we're not gonna waste too much of the time. I'm almost running out of space on my hard disk while recording with Nvidia ShadowPlay. This 8K video resolution, 100 megabit per second recording is not a joke, guys. Especially 1 hour, it's going to be like almost 100 gigabytes 100 gigabytes file size. So very high preset, 16x, advanced physics off, motion blur off. I mean low, not off, we cannot make it off. But very high preset, 7 FPS, still 7 FPS average without Nvidia ShadowPlay recording. Very high preset, 16K video resolution, AF16X, tessellation normal, now tessellation normal, still 7 FPS average, great FPS. very high preset, 16K video resolution, AF 16X, tessellation high, 6 FPS average. Very high preset, 16K video resolution, AF 16X, tessellation very high, 7 FPS average, 6 FPS average, I would say. Okay. Oops. Okay, here we go. So this is the last test, which is the 16K video resolution, AF 16X, preset very high, advanced physics enabled, tessellation very high, SSAA off, 6 FPS average. Okay. And then it's going to be a separator when I try to run with the SSAA on, and it crashed. Then finished. So I did the separator, and this is going to be actually at medium preset. Now it's low preset with the AF 16X, advanced physics enabled, tessellation very high, but low preset. So it's going to be almost actually 15 FPS average, and one benchmark didn't go well right here, the first one, but 16 FPS average, not bad. So this is the separator. This is the separator. We'll try to run the SSAA on, didn't work out. So now it's going to be within the Nvidia ShadowPlay recording. I'm just going to go through it, guys. So as you can see, 16K video resolution, I have 16X, low preset, everything else disabled, 17 FPS average. Low preset AF 16X now, not 4X, before it was 4X, and everything disabled. Same deal, 17 FPS average. Medium preset AF 16X, 16K video resolution, everything disabled. Within the Nvidia ShadowPlay recording, 15 FPS average. High preset, 16K video resolution, 16X, everything else disabled, 19 FPS average. Actually 7 FPS average. Yeah, 19 was a mistake on this benchmark right here. No, actually 7, yeah, it was right, 7 FPS average. Very high preset, 16K video resolution, AF 16X, tessellation off, physics off, 6 FPS average. Okay. 16K video resolution, F16X, very high preset, tessellation normal, advanced physics off, 6 FPS average. Okay. And 16K video resolution, very high preset, F16X, advanced physics disabled, tessellation high, still 6 FPS. As you can see, tessellation not a big deal for tuning GPU architecture, just like I told you. 16K video resolution, very high preset, AF16X, advanced physics disabled, but tessellation very high, maxed out on tessellation, still 6 FPS average. The last test didn't go through, as you saw. 16K video resolution, very high preset, AF16 on the texture, advanced physics enabled, tessellation very high, 6 FPS average actually. 9 was incorrect, the data was incorrect. The last benchmark will be low preset, AF16X, 16K video resolution, advanced physics enabled, and tessellation very high. So low preset with the maximum preset pretty much. On any other features and values, the preset will be 15 FPS average. Okay? Alright, so we're done with this, guys. And let me close that. Just because it's a world's first 16K video resolution benchmark, 16K gameplay, 16K video resolution Meta Last Light PC game, I decided to go ahead and give you, as a pioneer, the giveaway. Okay, let me open up. And the giveaway will be to the full license of the Meta Last Light PC game for Steam Game Client by UHDking. It's prepaid legal gift for you. All what you gotta do as the first activator, activate this code in your Steam client. It can be new account, could be existing account with more games to it. Again, it's prepaid license. And yeah, to the first activator, please let me know in comments below who you are. Do not state your first and last name. Just state I activated. Thank you so much. Blah blah blah. Here we go. So the rest people not going to activate that. If somebody will activate, this is only to the first activator. As again, Metro Last Light, the full game, guys, on a Steam game client. Okay, let me zoom out. As you can see, it's beautiful how small the Steam under the 100% zoom. Let me go through my specs, and we're going to go ahead and wrap it up. As again, this technology was available to us back in 2018, but I recorded in back of November 29, 2022. Let me use the zoom tool to show you today's date, like this. Okay, it's windy and snowy outside, drinking some hot chocolate and coffee, guys, and showing you a great video. The world's first 16K video resolution. Don't forget to smash that like button, guys. I'm losing my voice. So this is the specs. Let me bring the Titan RTX to stock so you're not gonna hear that noise. Here we go. You saw the value change, pixel fill rate, textual fill rate. This is while the GPU is overclocked, and bandwidth while the video RAM is overclocked changed as well. This is the benchmark. I done the benchmark without Nvidia ShadowPlay recording, and it was done when Titan RTX was overclocked, for those who's curious. And right here, guys, the value in terms of the NS stands for the nanosecond. The lower value is better, so it's latency delay between the hardware and software in terms of the nanoseconds. Memory will be the latency delay between the CPU and system RAM. So if I'm going to add more system RAM, the bandwidth, read, write, and copy is not going to change, and latency will be the same. Even if I'm going to add 2 more physical cores, it will be the same no matter what. Only if I'm going to improve the frequency on the DDR4 or frequency on CPU, it's going to increase, and latency will decrease. The low latency value is better, but the higher megabytes or gigabytes per second value is better. It's a bandwidth. Level 1 cache, level 2 cache, level 3 cache, read, write, and copy. Bandwidth will increase if I'm going to add 2 physical more cores, or even hyper-threading technology through the logical cores. I'm going to go way above 2100 gigabytes per second, but latency in terms of the nanoseconds will be the same, not going to increase. So you're looking at the latency if you're comparing pretty much, or if you're comparing your DDR4, you're looking at the read, write, and copy bandwidth as well. So pretty much this DDR4 was utilized as the fastest possible scenario. Pretty much, even if it was running 3200 megahertz, it was performing like DDR4 5000 megahertz because CL11 latency and 1T command. The low value of the latency, like CL15 or 14, will be slower. Keep that in mind. Okay, let me go through the CPU Z. This is the things. As again, 1600 megahertz times 2, 3200 megahertz because DDR4, CL11, 1T command. I was using 4 sticks, 32 gigabytes, 8 sticks each, but dual channel, 128-bit. But 4 sticks for dual channel is always the best scenario. Same sticks though, and same frequency memory. As again, it was Corsair 5000 megahertz DDR4 CL18, but unstable on this motherboard. 2500 megahertz times 2, 5000 megahertz. Unstable on this motherboard, which is the Asus Z390 chipset, but pretty much an old Z390 chipset, this memory will be unstable. So I utilized this memory because it was microchip, not the Samsung, so it doesn't like the frequency, it likes the latency to the best possible scenario. This is Titan RTX video card under the CPU Z, and this is the benchmark. You're gonna look at the single thread performance when it comes to PC gaming performance. When it comes to every single core utilized at 100% and overall CPU utilization at 100%, such as 3ds Max 3D rendering through the CPU or Blender 3D rendering through the CPU. When every single core is utilized, then you're gonna look at the multi-thread performance. The better is better. But single thread performance is when it comes to PC gaming, even the 2022 or older PC game, the single thread performance is the best in terms of the FPS. So 6 cores only scored almost 5.7 times, which is great for the Intel 9000 series CPUs. Right now I'm going to go through the different CPUs. Go ahead and smash that pause button and compare with your CPUs, but check it out. I'm almost as fast as much newer CPU with pushing much more instruction per clock, 5950X AMD Ryzen 9, but I'm as fast as that CPU running stock. So in games, it will demonstrate the same FPS. Smash that pause button. I'm going to go through the CPUs. Check it out. I'm dominating the 10900K by 40 points, by 60 points almost. This is the same CPU. As you can see, I'm dominating by 100 points in the single thread performance, so much faster in terms of the PC games, and it's dominating me in terms of more multi-thread performance because it's using not 6 cores, 6 threads, it's using 8 physical cores and 16 logical threads. When I'm using my CPU with the 8 physical cores, 16 logical threads, I'm like 5500. Keep in mind, my dual Xeon E5 2699 V3 scored almost 12,000 here, but above 10,000 score, but it was using 72 logical cores, but that CPU from 2013, but still faster as i9-9900K, using all cores stock in 3ds Max. Dual Xeon E5 2699 V3 will be about 50% faster, keep that in mind. But 13,900K CPU is running here 16,000 score on the multi-thread performance, so it's faster than dual Xeon E5 2699 V3 plus the i9-9900K with all CPU cores and logical threads. 13,900K CPU faster than that throughout the 3D rendering when every single core utilized at 100%, or in PC games. That CPU is amazing, guys. Cannot wait to test 13,900K CPU at my preset custom tune, which will be the fastest on YouTube. And you don't want to miss it as well. Subscribe and yeah, tune in to UHDking YouTube channel, guys. Alright, let me finish up with all the CPU cores real quick, and with all the CPU benchmarks versus my CPU. For those who's building used like new computers, the best possible way to build for the used parts by watching my videos and be smart. Okay, that's it, guys. That's pretty much it. Everything was covered. As again, yeah, right now I'm putting some great videos for you. As again, my name is UHDking, aka I play 4K, aka I play 8K, aka I play 16K, and today you'll learn why I play 16K or why UHDking, because I demonstrated world's first 16K video resolution gameplay, 16K video resolution benchmark in Metro Last Light PC game. And right now I'm putting some great videos for you to check out in 16K video resolution, or visit 15,360 times 8,640.com for more 16K UG videos, 16K resolution games, and 16K benchmarks. Have a great day, good morning, good evening. Support me, smash that like button. Till the next time.